Amazing. Thank you, Elaine. Well, I don't think I've ever seen so many screens on my screen with happy people. Lovely to see everybody. Good evening, everybody. I'm Lucy Pedler, founder and co-director of the Green Register. I've got my my colleague Elaine here, who you will have heard from and will hear from again. Elaine does all the pre and post event work to all of our online events. And on that basis, actually, I will just wait for even more people to come in. We're up to 80 at the moment. Once they're all in, Elaine, I'll just briefly go through this. Lovely. Yeah, so everybody's in now. Fantastic. I was just saying that Elaine here is my colleague, and she will be sending you 3 things at the end of this session. One is going to be all the presenters' slides. They've all very kindly agreed to send them to us, so you will get those. You don't need to make copious notes. The second is a feedback sheet. I know they're really dull, but I also know that speakers really, really appreciate them. These are 3 new speakers we haven't had before, so we'd very much appreciate if you could spend 2 minutes filling those in. Now, the third thing that we send you is a transcript of our chat, and I'm sure you're all completely familiar with this now, but if you have a question for our speakers, we've got a rapid fire schedule today, and we're not going to be answering questions until 10 to 6. So put all your questions in chat, which is the little speech bubble at the bottom. And as we go through, I'll be selecting them to present them to our 3 speakers plus our keynote speaker at the beginning. So I'm going to get going because of the amount of speakers we've got. So this is called Greenwash. What's a truly sustainable material? And I think it's really important for us in the construction industry to be able to have a look at some independent information, to be able to understand what is greenwash and what are products that we would really feel like we'd want to specify in our buildings. And we've got 3 exceptionally interesting manufacturers here today. But before we start with their pitches, if you like, I'm delighted to be able to introduce Alex Watson from Cleantrade. We were just talking prior to letting you into the meeting about some of the policies in relation to taxing high-embodied carbon products and whether or not this is coming in the EU or globally. So Alex, if you'd like to share your screen, we'll get going, and we'll be interested to hear what Cleantrade is doing in this field.
Thanks very much, Lucy, and for having me along. So yeah, really excited to cover a bit about what we've been up to. So just for those who haven't come across us before, so we're a new non-profit that's looking at different policy to boost low carbon industries of the future, try and make the case to tackle something which is long ignored, I think, which is high carbon imports undercutting fledgling low carbon industries, and we try to look at the policy solutions and what the positive effects of them can be. So I'm going to dive into a carbon border adjustment mechanism. So really that is a carbon price on imported products, and it will reflect both the emissions of their production of those products and any gap between the carbon price applied in the country of where they've come from and had it been made in the UK. And so this is a policy idea, and the basic logic behind it is that without government help, low carbon products may not be able to gain sufficient market share quick enough. And governments, of course, have an incentive to help because they want their countries to be making low carbon products of the future. So I'm just going to try to explain that with a few for the more visually inclined. So here is just looking at the UK and India, not of any product in particular. I'll come on to the construction industry and steel a bit later on. But this is just this graph here is just trying to set out the kind of principle that there are products that cost more money, that have higher emissions, and there are products that have higher emissions but have a lower price point. So you could say that in many industries in the UK, but also in other places. Those low carbon products or supply chain inputs are undercut on price by high carbon imports. And there are three basic ways that government can act in this area. One is what the EU is planning to bring in come 2026, which is to make the higher carbon inputs more expensive than the lower carbon ones through carbon pricing, which, as Lucy trailed, is a tax on products based on their carbon content. So this changes the dynamic in that, and you'll see in that little graph that the what was previously the cheapest product now becomes more expensive because it has to pay a tax based on its carbon. The medium carbon product has to pay less of that tax, but still has to pay a tax, and the lower carbon product becomes the cheapest and therefore gains a lot of market share. Another way of tackling this problem is through mandating or product standards. So mandating the reduction of those high carbon inputs. So in, for example, the Dutch embodied carbon building standards, essentially those higher carbon options are just ruled out, and therefore you get more of the market going to the lower carbon option, which and you'd hope that as volumes increase, those prices would come down. The US government is taking a different approach in that it's trying to subsidize those low or zero carbon materials with its Inflation Reduction Act, essentially providing subsidy for the zero or the lower carbon options. And you'll see here that that's a little bit kind of tricky and causes certainly some complaints around global trade, because essentially the other products from other countries with those same carbon contents can't access that subsidy because they're not based in the US. So there's kind of that a lot of these policies kind of interface with trade, but particularly the subsidies one. So hopefully these are kind of three high level ways of the options, and I've in my research been looking into the carbon border adjustment mechanism of those, and there are basic reasons why this appeals to both parties. For the Conservatives, carbon pricing sends a clear long-term market signal that helps unlock private sector innovation or investment towards low carbon products. Carbon pricing can simplify sector or product specific regulations, and it can avoid the need for the public sector to pick green winners. And there's also a leveling up element, not that you hear a lot of that anymore, but that there are low carbon industries, particularly in the north of England, that are being undercut by high carbon imports. For the Labour Party, this policy to introduce a carbon border tax could add further weight to what they've already been talking about in terms of a fairer, greener Britain. They've had some criticism around the public spending of their green plans, whereas this is more fiscally responsible, which means that it could bring money in, and then clearly it's tied to jobs, and so there's a promoting green jobs element. There's been some good progress in the UK. So the Climate Change Committee has been recommending a consultation on the carbon border adjustment mechanism for the last couple of years. There was a committee that recommended a consultation happened, and that consultation happened earlier this year. And the provisional timeline in that was set for 2026. I'm just going to run through the research that we did into how this policy would work when it comes to steel, and steel going into the UK's construction industry. So every year the UK imports a load of products, and 1.4 billion of the 500 billion that the UK imports is for long steel into the construction industry. That steel's been produced with varying amounts of carbon intensity. Here was some of the data that we got in terms of averages from these countries. So the Turkish and Czech steel is more carbon intensive than the Spanish one, and also the steel produced in the UK. A carbon border adjustment extends the domestic carbon price that UK steel is faced. They extend that to imports, and so products would pay a charge at the border depending on how polluting the product is, and that charge, the provisional plans are to follow, well, the details of how that is measured is being consulted on by the government, but the basic plan is to extend the emissions trading scheme processes for calculating carbon. So those have been in operation for coming up to 20 years. They essentially look at the biggest emitting facilities, require them to do scope 1 and 2 footprints. So the plan is to extend that to imports. So if steel is imported, the question would be asked, where's that steel come from, which facility, and then either the facility has the audited carbon footprint, or the government makes a kind of average based on what it knows about the grid of that particular country. So then with that tax, you would obviously expect some of the industry to shift. So we would estimate that of the 1.4 billion, over 500 million of that would shift. We don't know where that would shift to. It depends how easily the higher carbon emitting countries would shift their processes towards lower carbon steel manufacturing, and clearly alternatives like the total lower carbon alternatives, be it the recycled steel from electric arc furnace, or other alternatives, timber, for example, being one. I looked at how Segro, a leading industrial property developer, how much pipeline they had. They don't publish information about where their steel comes from, so we just applied what we see across the industry to them, and their footprint, their steel purchasing, we estimate that about 10 million of that would change. I think what's interesting there is Segro is a FTSE 100 company. This is quite a small line item for them, and that's really my sort of takeaway from this research, is that while this is a big deal in the world of steel, because steel is only one of many components for the construction industry, the actual effect of this policy could be, we're still looking at significant numbers like 10 million, but for some of these big construction companies, that is not a big line item. So shifting the incentives, yes, does create extra costs, but potentially in targeted areas that are the highest carbon products, to shift the kind of economy towards lower carbon practices. So in sum, I kind of conclude that the carbon border adjustment is an opportunity for the UK's fledgling low carbon steel industry by allowing it to compete on a level playing field with high carbon imports, and incentivizes supply chains around the world to decarbonize, and countries too, because those products come from countries those products from countries that pay the same carbon pricing don't have to pay it twice. So if, for example, Turkey decided, as it is currently considering, to bring in carbon pricing because it exports a lot of steel to the EU and UK, this policy incentivizes them to put in a carbon pricing regime so that they get the tax revenue from the carbon price rather than the UK at its border. So that's a kind of quick whip through of carbon border adjustment and steel. I've kind of wrapped things up there. I've got some more detail to go into, but I want to be conscious of time and leave plenty of time for questions.
Thank you, Alex. You finished before time, so if there's anything else you wanted to say just before we move on, please do so.
Yeah, I mean, what I could do is just maybe leave, just I think one other point that is interesting about Segro, the company that we kind of zoomed in on as a case study, is that they have a CDP score of an A. They have an approved science-based target. They have a target to reduce the embodied carbon intensity of their new developments by 20% by 2030. For me, they actually express in their CDP survey that they don't really have a plan of how to make this reduction in embodied carbon happen. So for me, I think there's lots of companies out there. A majority of FTSE 100 companies have a science-based target. So actually, these kind of policies are pragmatic ways that the government can incentivize the shift towards a lower carbon economy in a way that is building on this emissions trading scheme that's been there for the last 15 years, setting clear expectations that carbon is going to be priced. And so, yeah, I am kind of now doing some work to engage these kind of companies to help them understand that this kind of regulation doesn't threaten their core business, and actually it helps them to be able to hit their science-based targets by shifting the practice of the steel industry. So that's probably one thing to follow up on there.
Yeah, thank you, Alex. And for those of us who've been working in this field for decades, it's music to our ears to finally see that the environmental cost is being folded into the financial cost. But it's been a long time coming, and we wish you the best of luck with that. And we'll be very interested to see what the subsequent three speakers here today think of this. I'm sure they'll be in support of it. So if you'd like to stop sharing your screen now, thank you. We are going to be having three manufacturers speak now. So the Green Register has picked these three because we believe that they have a product that is sustainable on many levels. They're very brave. They've come to talk to you all to, if you like, pitch their products, not a sales pitch, but just to explain what they feel the sustainable criteria are for their products. And then hopefully we'll have time at the end to be able to look at all of them in the round and reflect back on what Alex's policies might affect the three of them. So the first speaker I'd like to introduce is Sam Chapman. So he's the co-founder and the MD of Kenoteq Bricks. So Sam, if you'd like to share your screen, please.
Hello, everybody. Yeah, give me 1 second.
Great, thank you, Sam. Yeah.
Thank you. If everyone can see this. Yes, and thank you to the Green Register for having me this evening. I will try and keep to time. Please do nudge me if I get excitable and overrun. So my name is Dr. Sam Chapman. As said, I'm the CEO and co-founder of Kenoteq. We are a spin-out company from Heriot-Watt University in Edinburgh. And my background, I was originally trained as a structural engineer, and then I went on to do a PhD in life cycle assessment of civil engineering projects, which is when I met my now co-founder, who was working on a new material, which was all made from recycled demolition and construction waste. And I'm going to come on to tell you all about it. So really the sort of critical kind of problems that we were responding to was all around the construction and demolition waste materials that were in the system, both locally, both within the UK and indeed globally. And still more than a third of waste in global landfills is from construction and demolition. and we are running out of raw materials. Certainly in Kenoteq's world, I'm going to come on to tell you about our product, a brick, but clay resources, indeed cement resources, certainly within the UK and Europe, there are less and less licenses being granted. There is an awful lot of exploitation still happening of the minerals from the earth, but being in restrained countries, this is becoming less and less. And these have been the incumbent, very high carbon products in the system for many, many years. Obviously, we've heard a bit about steel just now, but the cement industry, if it was a country, it would be considered the third highest emitter on the planet. So a huge, this is a huge consideration and a huge issue. And this all also feeds into this, the construction waste material that is continuing to find its way into both landfill, and waste handlers stockpiling this material and needing new avenues. So Kenoteq's solutions to this is looking at circular economy closed loop processes for the construction industry, and we intend to build and to make new building materials out of as much of that resource, of that recycled material as we can. So repurpose this waste, and I get stuck using the word waste because I don't want to use it. I want to use the word resource. But this is still considered a waste within society, and we need to get away from that. These are valuable resources and materials that are in the system, and we need to use these for a sustainable future, because without that, the traditional linear approach of exploiting simply won't be able to continue. But also we want to do this in a state of the art, in a modern way, and use state of the art equipment and technologies, which I'll come on to a bit about what I mean by that. So our first product is the K brick. So we've launched this as an exterior facing brick. This is to try and look to start replacing these high traditional clay fired and cement based bricks that are currently used. Over 2.5 billion bricks are used a year just in the UK, and we're still importing over a fifth of these. So 500 million are still coming from the continent, from Northern Europe, and indeed further afield. Our K brick is made from over 95% recycled construction and demolition waste. These are recycled aggregates, recycled gypsum from waste plasterboard, recycled pigments, and also our binder that brings the product together, which is our sort of secret sauce. And we don't fire the product like a traditional clay fired brick, and we don't use any virgin cement. And all of this basically results in a very, very low embodied carbon number for our product. So our K brick is just 20 grams, is below 20 grams of CO2 per brick. Comparing that to a clay fired brick, which is about 455 grams of CO2, it's a huge, huge reduction. And we feel like we're basically one of the first, if not the first, to market with such a product that is so ultra low carbon when compared with those traditional incumbents in the system. And if you think about commercial builds that may be 40 or 50% concrete and or brickwork, to be able to immediately drastically take a chunk off that means you're having a serious impact on your embodied carbon targets. And indeed, we just heard a little bit about that from Alex with regards to the Slough Estate Group, what they're looking at to reduce. These types of products that we're launching could absolutely help towards that. And what we're doing to ensure there's a certified number for that embodied carbon is we're working with the BRE for an environmental product declaration, which is kind of key for the building industry to get this product out there. And we're also protecting it through an IP strategy and indeed patents to make sure that we're protected and are able to get this out into market without some of the very big traditional incumbent companies out there challenging us, which I'd happily debate after this. Just a bit more on that, these sort of comparisons. So the CO2 emissions, our energy use on site, and the waste generated. We have a zero waste strategy. Any product material that we make that we either test on site or we're not happy with goes straight back into the system. By the very nature of using recycled materials, we can reuse any materials on site. There's no additional wastage from our process. It's been a long road to get here, and one of the key areas is certification. So we're just finalising our technical certification with the BBA, the British Board of Agreement, and as I mentioned, the kind of the sustainability and the carbon certification is with the BRE. And we have a strategy to enter the market, which is both short term, which is working on interiors, mid-term, which is kind of custom build, self-builds, and then long-term is public sector. So we're based in Scotland. There are now mandated carbon targets per square metre of all new public buildings, be it hospitals, schools, universities, etc. And indeed Wales. I'd encourage people to look at the NHS decarbonisation strategy, which is very, very interesting reading, and they're really targeting this embodied carbon now after, the industry's largely got to grips with operational carbon, but now this is the big elephant in the room, which is embodied carbon. And that's exactly where sort of Kenoteq is targeting. I don't want to read and go through too many of these, but these are some of the sort of trends that are happening and indeed the mandates. And I would hope some of these are familiar to yourselves. But we've got our net zero carbon targets, and indeed now regions are taking this on much more than the kind of overarching UK desire for net zero by 2050, and particularly in the likes of London, central London, City of London, are really challenging some of these quite far away targets and trying to bring them forward. As I mentioned, sort of the Scottish public sector are really trying to do this. And it's encouraging that they're targeting things like hospitals, schools, university buildings, because I think that's, for the future, I think that's really encouraging first steps, but obviously plenty more to be done. And indeed, a bit wider, there's things like the Circular Economy Bill in Scotland, which is all about resource efficiency. And again, that sort of goes back to my original points about this material, these recycled resources that are in the system. How can we better use these without having to exploit or indeed bring in, import materials, products from elsewhere? And as I mentioned, the K-Brick can allow projects to really achieve these carbon targets. We need proper metrics, we need proper ways of measuring this, hence why we're going down the environmental product declaration route. Sure, it's not perfect, but it is an industry standard at present. And we feel that's an important starting place. I'll just very quickly mention, so we've got our first production facility, which is just outside Edinburgh. It's in East Lothian. Been a significant investment to get it to this point. We can currently make about 1,250 K-bricks a day, but we are going through an investment process at the moment, and we're hoping to raise this to 20,000 bricks a day. That equates to about 5 million bricks a year. As I mentioned, it's there's a demand of 2.5 billion. So this is still very small steps, but this is important steps for us as a company in entering the market, and it has been a long road to get here. But we've taken the challenge of being manufacturers ourselves within the UK, doing it ourselves and not just licensing this, to others. We really want to be able to do this ourselves and really show that, a new sustainable product can enter the market. We can do it ourselves with some of the support from the industry and from government and regulators. But, there is potential here to really start revolutionizing and changing the construction sector through circular economy practices. These are just a few snapshots of the product in use. So a couple of restaurant jobs. We've got some trials with some large contractors up in Scotland, and the bottom left was a nice wall we did for COP26 in Glasgow. This is a concept about the growth strategy. So we intend to bring on a new product year on year. Obviously, we are starting with the K-brick, which I will waft in front of you. Forgive me for the show and tell. Looks, acts, and feels like a brick. But also we've developed what we're calling a slip product, a K-slip, which is like a brick tile, which is also fitting into modular and off-site construction, because we don't want to make a product that's too backwards. It's got to be innovative. It's got to keep with the with the industry and where the industry's going. And we are, within 3 years, we're looking to launch a franchise or license model so we can almost democratize this. So waste handlers and or developers or urban regeneration projects can make their own K-bricks as long as they've got access to the material and the resource, and really help to drive a proper scaling and expansion of this. So it's not just one company doing it. We can really start to replicate through a wider kind of OEM joint venture or license type model. That is it from me. I'm sorry if I've slightly overrun or if I've talked too quickly, but these are just some of the comments and some of the coverage we've had about this product. An awful lot of interest in products like ours, and we think that's really exciting. But we just hope that this space continues to grow, and I'd like to think that these sorts of events and hearing about it will really help to shape that. So thank you very much. for listening.
We do too, Sam. We hope that that will grow. It's a fantastic, exciting product. So I've got 3 very quick questions. So if you're already producing it, it's on the market, is it? You can buy
it? Yes, you can, yes, but it's not yet certified. So we're in the final throes of certification with the BBA. So we've got about 2 months to go. But for interiors, for demonstrators where people are willing to take a punt or temporary type projects, then it is for sale, yes.
Okay, and you said it doesn't go through a firing process. So is it structurally, can you use it for structural?
Yes, you can.
Yeah.
It's not like an engineered brick, so it doesn't have the very high compressive strengths, but for 80% of the market, for what most bricks are now used for, bricks aren't used structurally as much as they used to be. It does 80% of those applications. So this is an exterior facing product, and it has some structural integrity. So the strength is 30 megapascals. Above that, it's up to a structural engineer to sign it off, but it can be used within that sort of 80% realm. Yes.
Fantastic, Sam. And would you be kind enough to put the link to the NHS's decarbonisation aspirations or targets, so in the chat for everybody to have a look?
Yeah, absolutely. Yeah, there's a very good few reports on it. So.
Yeah, I think for those who are working in healthcare, that would be really helpful. So Alex has already addressed a couple of questions that came after his talk. If you just keep an eye on the chat, you've got 2 already. If you'd like to reply to everybody, because we do send this as a transcript, then people have a record of it, that would be amazing. Thank you so much. If you'd like to stop sharing your screen. And I'd like to introduce our next speaker, Eunsun Nightingale, who is the MD of Margent Farm and also COO of Hemspan. I came across the external cladding that Margent Farm produce. It's a beautiful, soft, corrugated product. I don't know, it was probably a year ago or so, and I've been very keen to have them speak at the Green Register. So I'm delighted to be able to welcome Eunsun. If you'd like to share your screen now. Lovely, thank you. You probably know you're on mute, Eunsun.
Can you hear me? Can you see this as full screen?
Not yet, no. It says it's in full screen. There we go, perfect.
Okay, sorry about that. Minor technical. Thank you everyone for joining, and thank you Lucy and Elaine for inviting me. I am Eunsun Nightingale, and I'm actually here on behalf of a few different companies I work across. As Lucy mentioned, Margent Farm, which I've been working with for the past about 4 years now, and Hemspan I joined about 2.5 years ago. And Margent Farm, which is an interesting and exciting new venture that Margent Farm and Hemspan are coming together to create in the next coming months. So I'm excited to actually tell you more about that in the next coming months when we're actually ready to talk about it. But today, my presentation is called The $1 Billion Crop. And I wanted to take a step back and really talk about why Margent Farm and Hemspan really focused on hemp as a primary foundation for all of our materials, and why this is such an amazing superhero of plants. And to take a little step back and talk about the history of it without being too lengthy on the process of it, but I wanted to maybe go back to 1938, when this was deemed the $1 billion crop by Popular Mechanics. I don't know if any of you have seen this, but this is a very well respected science and technology magazine in America. And 85 years ago, they had actually hailed hemp as the first $1 billion crop for the future. The article went about the various uses of it, how it's been used, and how it's going to change the future of all materials in general. And then after it kind of disappeared. And but the reason why it was hailed as a $1 billion crop was because of the amazing characteristics of hemp as a plant and what it can do from seed to growth. So I can actually spend probably an hour talking about hemp, but I will only bring 3 key points and keep it very, very brief. And one is the historical uses. It does date back to 10th century BC, from the ancient Greeks to Chinese to Egyptians. This first record of using hemp in the UK, the Anglo-Saxons, I believe, was 400 AD. Everything from sails to ropes to medicine to clothing. There's this vast history of this amazing plant that is, quite historical, that has been utilized in this natural, beautiful, strong way for many, many, many years. And why is it relevant to us today, which is my second point, is because of the environmental impact. It's not only a plant that could grow in 90 to 120 days, very, very short life cycle. In a very warm climate, you could have a few harvests a year. In the UK right now, there is 1 harvest per season, 90 to 120 days, planted between May and harvest in September. And many of you might know that as it's growing from seed to full size, sometimes 3 meters, it can capture and sequester carbon. But in addition to that, it actually sequesters carbon and pulls nitrogen from the air and climate and puts it back into the soil. So this is the reason why it's an amazing rotational crop. So farmers will actually plant hemp in between all their other corn, wheat, whatever they may do, to actually bring health back into their soil. It needs no or little pesticides, just needs a bit of nature, sunlight, and a bit of rain. It is a weed, so it does grow very quickly, and it's very robust. There's no waste from everything from the stalk to the flowers and seeds. All of it can be used in some capacity. And in what we know of today, there's over 50,000 uses of hemp. Everything from textile to food to animal feed to automotive industry. The first Henry Ford Model T in 1941 was made out of hemp. Mercedes, BMW, Volkswagen all use hemp in their cars, as well as now we know in construction, because hemp is 20% harder than oak wood and it grows not in 10 to 15 years, but in 4 months. With all the amazing attributes of hemp, why has it gone under the radar for the last 85 years? Because of the marijuana tax of 1937, which legalized marijuana, because it was demonized as a plant that was leading to naughty behavior, and hemp was actually categorized with marijuana at the same time, which was then overturned in 2018 with a Farm Bill. And it's relevant to us today because we've now replenished and rediscovered the amazing uses of this natural material. And especially in the construction sector, which is what I've joined in the last 5 years, learning about the environment and learning about the impact of the global climate change, where 39% of global carbon emissions is responsible by the construction industry. Vastly, a lot of it from the actual use and heat and energy and the way that we live, but also from the actual construction process. Which brings me to Hemspan and Margent Farm and what we're doing and how we're doing it and why we're a bit different. So we do have over 5 years of R&D. We are in the business and in the industry of actually creating products made from 100% hemp, but also we're creating demand. So we take our products, we take all of what we learned from R&D, and we design and we build our own houses. We are in the midst of building houses in Borough Green and Newmarket, which I'll get into later on, but we're also working with farmers, processors, our own manufacturing, and working within the full supply chain so we can control from seed to the end user, which is ultimately us, you, everyone in between. I want to talk a little bit about introducing Margent Farm, which is what Lucy touched on before. So Margent Farm, the hemp flat house, which I'm not sure if many of you know, but is a house that was built from hemp from a little farm in Cambridgeshire called Margent Farm back in 2019. This house was built on 38 acres of hemp that was first planted in 2018. Steve Barron, who's the founder of Margent Farm, decided to grow hemp after he bought this beautiful property. And based on this amazing first harvest, we were lucky and able to find engineers and other collaborators who helped take it from seed to what is now the corrugated panel, which you see on the bottom right. So this is made from 100% hemp fibers, which is the inside of the stalk, and bioresin, which is essentially farm waste. And after a bit of testing and some trial and error, we were able to create this beautiful corrugated panel, which you will see is on the outside facade of this flat house. The interior is all hempcrete and built in 2019. We do have events and open days at the farm where you can see the hemp house being built and learn about the whole process from growing hemp all the way to processing and manufacturing. And then Hemspan is another company that really stemmed from the inspiration of Margent Farm, but Matt Belcher, whom I met through Margent Farm, came to us and talked to us about building systems and taking hemp to another level of building entire houses completely of hemp and making it very accessible to the mass, commercial scale. And we absolutely love the vision of it. And so when he approached me in 2020 to join Hemspan that he was launching, I agreed while still working alongside Margent Farm. And fast forward 3 years later, we have a suite of building products, everything from insulation to structural boards to alternate plaster boards. And now we're introducing an entire building system, which is offsite manufactured modular paneling housing that is timber structure, but hemp from interior to exterior. We're building our first 5 homes in Borough Green, Newmarket in Essex, this hopefully end of the summer. We're in the midst of construction now, and we have a few others, Mutford Wood and Brand, and that is also in the final stages of planning for this year. And we have, in the next 4 years, 550 homes that we're delivering, which is completely net zero, climate positive, hemp-based homes, which means that at the end of the completion of those homes, we will have captured 26,000 tons of carbon. And all of our bio homes are actually built with passive house principles, but bio-based materials, which means it's actually an active house, so it's all breathable. So the performance between winter and summer, it creates its own microclimate. There's very low VOC, which I'll take you to the screen, which talks about how the structure of the biohouse is made, from the hemp insulation to breathable materials, heat exchanger, cross and stack ventilation, carbon negative construction, and insulated raw foundations. Apologies for the diagram being so small, but you'll all get this at the end and you can ask questions if you need. Some of the challenges we faced bringing hemp into the UK, we went through a lot of processes, even from getting our own hemp license, growing our own hemp, going through the whole manufacturing process. And a lot of it was, can we smoke your house? Can we do this? No, you cannot. So there was a lot of education that came into play, and we approached everything with an open mind and having a heart to really teach people about this material that can be so flexible, so versatile, so strong, and really changing the face of not only construction, but anything that you can do with this amazing material. So we approach everything with having an educational platform. We host demonstrations. We will attend exhibitions and events. We have online platforms. And we take everyone from the whole process of growing all the way to manufacturing and the end product. We also believe in transparency. We don't know everything. It is still, to us, a new product. We won't have the same type of history as plastic or things that we might be very familiar with and take advantage of in everyday life. So there is a growing journey that we have to go through with the consumer, the end user, the builder, that let's be patient with this material. It is natural, it's better for the world, but not everything is comparable to what we might be used to in our everyday life. And the fourth is flexibility, is where we had to shift our business, shift our products, learn from our mistakes. As Sam mentioned, going through testing and certification, it's very difficult with natural materials. You cannot compete with what we're used to in the traditional space. So we have to actually shift what our expectation is and realize that we don't need the forever product. We don't need it to last for billions of years. We need to last during our lifetime and to be better for the environment in the future. And last of all, collaboration is really about working with all the industry leaders, the engineers, the designers, the architects, the builders, the consumers in the end, and sharing knowledge, sharing a platform, not competing, knowing that there's enough in this space that we can actually all learn, build, and promote, and help each other to actually bring all natural materials into the forefront. So I leave you with this. We in the heart of transparency, we always open our doors to our R&D shop, and we do host events that are meant for the customer, the builder, designer, the architect, whoever you may be. We'll be hosting 2 events this year, one at Borough Green, which is our building site in Newmarket, where we will be showcasing our first 5 biohouse homes, and we'll have demonstrations. We'll talk about how the material is made, how to actually install it, everything from thermal measurements to view values to how to actually take care of it and the durability. And the second event will be at Margent Farm, where we talk more about the farming, the agriculture aspect of it, how to cultivate the land, as well as having demonstrations. We'll be announcing the dates for these in the next coming weeks. So we invite you, if you want more information, you can visit our website.
Eunsun, thank you so much. I actually think that the Green Register should talk to you about having our own site visit that we organise with you. In the interest of time, because we're running over a little bit, if you'd be kind enough to look at the chat box, because there's several questions there for you, and you could answer them so that everybody can see your answers. And we'll move straight on to our final speaker, who's Roly Ward. Roly is the Head of Business Development at MEDITE SMARTPLY. So Roly, can you please share your screen? Fantastic. Yep. Full screen. Yeah, lovely. Thanks, Roly.
Good. Okay. So thanks, Lucy and Elaine, everyone at Green Register for inviting me today, and then thanks everyone for your attention. And we'll get through this in the next 10 minutes or so. It's important to look at who we are and who MEDITE SMARTPLY are today, what we do, how we sustainably produce our products, which are made from timber. Many of you are going to be familiar with MDF and OSB, but it's important to look at how those products are produced, and in particular some of the products themselves and the applications, and also we'll look at some of the specialist panel products as well. Timber's on an upward trend of being used in construction, but at the same time we've got to solve more problems with the products that we're producing as well, because they're entering or displacing others and entering into new spaces. So we'll look at some of those. So who are MEDITE SMARTPLY? Well, we're part of the Quiltshire Group, which is an Irish state-owned commercial company. As a group, we operate in forestry, land-based businesses, renewable energy, manufacturing of wood-based products. As a group, we own 442,000 hectares of land in Ireland, which is all FSC and PEFC certified. That's approximately about 7% of the land mass, in Ireland. And Quiltshire itself is spelled COILLTE, but it's pronounced Quiltshire, which is it's like the quill of a pen, but with a ch at the end. So, you know, as a timber manufacturer, it's important to look at the forest cycle, you know, and wood is a sustainable material. So, you know, as a group, we plant about 20 million trees, you know, on average a year, and that creates about 7,500 hectares of new forests, 4 nurseries, 12 different species, 7 million plants every year. You know, Ireland's a really good place for growing trees. There's a lot of rain. The climate's perfect. You know, and that's really good. You know, especially you know, for Europe in helping to reduce, you know, climate change effects. You know, typical tree you know, absorbs around 21 kilograms of carbon dioxide a year. You know, and over the lifetime of 100 years, you'd expect that to absorb about a ton of CO2. In terms of managing and protecting that land, you know, as I said, we own 442,000 you know, hectares of land, which is, you know, 70% of the total land mass of Ireland. So there's a lot of responsibility there. But, you know, to put that into perspective, 20% of that is managed for biodiversity. Everyone will recognise the FFC and PFC, you know, trademarks, and you know, transparency has been a word that's been mentioned, you know, several times today, and you'll see those logos and everything from sort of Christmas cards to timber studs, but they're really important. You know, they give that real transparency that the materials come from a sustainable source. You know, that the chain of custody is not, you know, is not broken. Culture itself, you know, we're the largest producer of roundwood, you know, which is the raw material that a sawmill customers use. They process that into high quality timber products. And you know, Sitka spruce is the main commercial tree species that we use. You know, an annual production of that is about 2.6 million cubic meters of roundwood. So, you know, throwing around a lot of numbers there, but you know, the point being that, you know, we're talking about huge scale. We don't use any hardwoods or tropical woods, you know, particularly in the OSB manufacturing process. And OSB, you know, and MDF are produced from the thinnings of the trees as well, so the small diameter logs, which is very different to something like plywood, which needs a larger veneer from a tree that's perhaps been growing for the sort of 40 to 60 years. Yeah, and in terms of building with timber itself, and lots of numbers, you know, been used today, and really interesting, you know, what Sam and Alex were referring to earlier with steel and concrete. You know, buildings are responsible for 39% of global energy-related emissions, and 28% of that is from operational, you know, emissions, and that's from, you know, just the energy that we use to heat, cool, and power our, you know, particularly our homes. And you know, remaining 11% is from materials and construction. So, you know, choosing the right materials to build is going to become, you know, increasingly more important. You know, as has been mentioned earlier, just 3 materials alone. You know, we calculate, you know, just concrete, steel, and aluminium are responsible for about 23% of total global emissions in the built environment. And you know, wood panels themselves are a carbon sink, so they retain the carbon that's been sequestered from the atmosphere. You know, and certainly over the next few years, you know, wood is going to be one of the most important resources, you know, that we've got for sustainable construction. You know, interestingly, the Future Homes Standard is coming into play in 2025, and we're going through a sort of consultation period at the moment. But it's, you know, it's aimed at reducing carbon emissions from homes by about between 70 and 80%. You know, and from our perspective, you know, the regulation, you know, really promotes a fabric first approach, and you know, the use of timber as a kind of natural, renewable, low carbon material. In terms of the raw material that we use and its journey and where it goes, and the material used to produce, you know, OSB and MDF comes from the thinnings of the trees themselves, so not actually the main logs, so the small diameter. And again, you know, that is different to other woods that are produced. You know, the logs will then either go to the sawmills, or they'll be chipped, and they'll either go to our SMARTPLY factory, which produces the OSB. Or they'll go to our MEDITE factory, which we'll come on to talk about those shortly, for wood panel production. Any waste at all then goes to biomass, which is then used as a renewable source to heat, predominantly heat the cooling process, or power the cooling process on our manufacturing lines. We'll look at some of the applications of OSB and MDF, shortly. But it's important to know that they now, there's now a really large range of products, across those range of applications across those products, and everything from sort of fit out to dry lining, site protection, roofing, timber frame, and everything around modern methods of construction as well. You can even produce flame retardant products now, moisture resistant products, products with no added formaldehyde whatsoever. You can even produce products that contribute towards passive house with vapor control that have got airtight properties as well. So we've come a long way with those products, certainly over the last 10 years. If we specifically look at MDF, and for anyone who's not aware of MDF, and I'm sure most of you are, but it's an acronym for medium density fiberboard. It's a really smooth, consistent board. It's exceptionally well suited to kind of machining, grooving, cutting of any size, very little waste, finishes exceptionally well. Very good with solvent-based paints, natural veneers, and it's got hundreds of applications, but predominantly, interior use for kitchens, bedrooms, bathrooms, wall linings, furniture, but not generally suited to external applications. That picture there is a picture from our plant in Clonmore and Tipperary in Southern Ireland. That's where we produce, a huge range of specialist and technical MDF grades of products, again, that look at, moisture resistant, flame retardant, zero added formaldehyde. And we've produced that in that factory for the last 30 years. We've even got an MDF panel that we've developed for exterior application there that comes with a 50-year guarantee. So again, we mentioned a lot of the applications for MDF. Most importantly, all of our MDF products are CARB phase 2 compliant. So that's a regulation limit lower than the E1 formaldehyde class levels, and we've got EPDs for all of our products as well as all of the relevant ISO certification. And we estimate that the market around 12 million cubic meters of MDF a year is consumed in the EU in the UK, and MDF certainly takes a huge amount of market share now from particle board, which it didn't in the past. It competes with softwood and interior applications for skirting boards. It has no knots, better machinability, excellent consistency, and it's certainly very cost efficient alternative nowadays. If we quickly look at our manufacturing process, it's very similar to OSB. That the wood chips go through a process where they're refined. They go through a drying process. Glues and waxes are then added. The product's then formed. It's pressed. It goes through a continuous press before being cooled, sanded, and then sawed at the end of the line. It really is actually as simple as that, but on a huge scale. And if we look at OSB, OSB is oriented strand board. It's designed and manufactured for a variety of structural and non-structural applications. That factory there produces around 380,000 meters cubed of product a year. And not just ourselves, but a lot of timber manufacturers. There's been a lot of investment, particularly over the last 10 years. We've been preempting the increased use of timber, and we're not alone with that. We've had two investments. One was a £59 million investment. That created a new forming and finishing line, and then a state-of-the-art continuous press. As we talk about sectors that we're working in, modern methods of construction, particularly off-site construction, there's a demand there for a longer length of panel to reduce time, to reduce waste, and we've got to react to that. There was also a €44 million investment as well which is a huge upgrade to our drying, energy and screening facility. So that facility now operates on 100% renewable biomass material for the process of drying and heating, which was the main use of energy consumption in the plant. Every SmartPly product is produced with no added formaldehyde, which is really important. There's some really stringent global emission standards that we're trying to meet, both with formaldehyde and VOCs. And that plant there is based in Waterford, and as you can see, it's really adjacent to a deep water port. So in terms of carbon footprint and transporting that product over to the UK, then that's reduced to a minimum. So in terms of OSB itself, OSB consists of strands of wood, and they're arranged in three layers, as you can see there, in the image, and they're bonded together with a synthetic resin adhesive. And the wood strands, the outer layers, are orientated in the same direction as the panel length, are different to those in the core, which are at right angles to it. This gives it incredible strength for structural applications, and really good for construction of buildings. It's a solid panel. There's no core gaps, and there's no delamination at all. Under normal use. The process, again, very similar to MDF, and I won't go through all of that, but again, it goes through a process where the product's formed, it's cooled, it's pressed, and then cut before being transported. In terms of application, we estimate around 6.5 million cubic meters of OSB is consumed in the EU and the UK every year, which is massively increasing. OSB panels can be cut to size. Pattracing can now be done. Panels can have a Euro Class B rating for improved flame retardant resistance. All of our OSB panels have all got EPDs. As well as all of the ISO relevant ISO certification, and most of the OSB panels that we produce go into the construction sector. We start to look at more of the specialist panels, and sadly there are a lot of arson attacks on sites, and our fires during that construction phase, of buildings. Timber components are protected from while a building is being built. Timber components are not protected from the effects of fire. Internal linings, external claddings. So there is a requirement for a temporary solution, and advances in technology have allowed us to now produce an OSB panel with a Euro Class B certification. Something that we get asked a lot about, can OSB be airtight? Can it be used, be suitable for kind of low energy homes or passive house constructions? Yeah, absolutely. there are coatings now that you can apply to OSB that will give it airtightness. It's a structural panel as well. It has an integrated vapor barrier. In a passive house test typically would be pressure of 50 pascals. Over the course of an hour, and an airtight OSB has been tested up to 2,000, in terms of air pressure. So it's a really robust product, and the coating is a UV cured coating that creates an integrated vapor barrier and guarantees airtightness. And that's everything from me. Sorry to rush you. I'm conscious of time.
That's absolutely brilliant, Rory. Thank you. And considering how much we use these kinds of boards in construction, it's really interesting to see how we can reduce the overall environmental impact of OSB and so on. I'm going to read a few of the questions that have come to you. The other speakers have been very kindly populating the chat, so you'll get those, guys. But I'm because we're practically out of time here, just fire these at you, Roly, if you're okay with that. So. David says, do you manufacture a structural board which is breathable and comparable to the German-made board like panel vent?
Yes, we do. It's called Vent. Probably the easiest way to explain that is just to go onto the website and have a look. It's MEDITE Vent, and it's a breathable structural panel.
Fantastic. Panel. Thank you. Debbie says, I understand you plant mini spruce, but couldn't quite hear what, if any, percentage of deciduous trees to allow biodiversity at ground level.
Oh, good question. There's probably a very clever answer to that. I don't have it in front of me.
Okay, that's fine. We can't expect you to have all the details. Could you find out and we can send it on?
I can find out for you.
Yeah, I hope that's okay, Debbie. Thank you. Les says, what's the source of the binding resin in MDF and OSB boards? The binding resin.
Phenolic resin at the moment, we're looking at bioresins. We are restricted by technology, essentially, within those materials. We've got several things which we're looking at and researching at the moment. The technology is catching up with what we need. So the answer is we will have a bioresin that we'll be using can't put a time on it, but it will be shortly. At the moment, it's a phenolic resin that we use.
Excellent. Richard asks, how are MEDITE SMARTPLY products recycled at the end of the initial use?
So repurposed and reused. You know, any offcuts in our manufacturing process go straight back into either biomass or into product as recycled content.
Great. Joe says, is FSC the only option being used for this product? Is it possible to use pulp or other recyclable materials already in the system rather than manage woods? You know, a bit like Kenoteq, I guess. Just thinking about the lack of forests in the world and rewilding being a priority.
Yeah, there's enough wood fiber at the moment. It's sustainably managed, our process, and so yeah, if we needed to. Yeah, if we needed to look at alternatives, and we will. There are other things that we've looked at putting into hemp, actually one of them putting into products as well. But you know, it's a sort of farming sustainably managed process. The growing of the trees in terms of the consumption of wood fiber that we use as well.
Fantastic. Well, guys, I think we should probably close. I would like to warmly thank all 4 speakers for fantastic presentations. Really, really interesting. It's an area that I think is going to have a lot of growth as we get our energy and use under control. We have to look at the embodied energy. I'd like to thank Eco Merchant, who sponsor all our Twilight talks and allow us to hold them free. If you're not already a member and you'd like to become one, please get in touch. You get huge discounts on the events that we run throughout the year. We've got loads and loads on our website, so do have a look at those. Your speakers are getting lots and lots of thank yous. Thank you, everybody. We will send you this transcript and have a good evening.
That's great. Thanks, Lucy. Thanks, Elaine.
Yay!